So we're just going to finish up this the solutions to the worksheet, 3.4 concepts worksheet. So we're on part D. We're trying to graph the acceleration. And the way I did this in class was I set up a chart, and we'll do that again. We're just going to set up x, did I do that in class? X I did. So it should be a t, and then what are the slopes? Well, from t equals just past 0, so let's say 0.1, all the way to 2, we can see that the slopes, if you go down 2 and over 1, are all negative 2. So the slopes are all negative 2 from t equals 0 to t equals 2, or let's say 1.9. And so let's go ahead and graph that from t equals 0. From t equals 0 to t equals 2, the slopes are all negative 2. And so we just, basically we're telling a story about what the slopes of the velocity graph, slopes on the velocity graph are from different values of t, 4 different values of t. And if we start at 2, do that again. We can just pick values of t and figure out what the slopes are. Well, where do we want to start here? If we pick the value of t from t equals 2 to t equals 3, so this little section right here, if we go down 1 and over 1, we see that the slope of that part is equal to negative 1. So right here on the graph we have the slope of negative 1. Over here on this other part of the graph, the slopes here were negative 2. Okay, so that's why the graph of the acceleration is negative 2 between 0 and 2, and the graph of the acceleration will be negative 1 from t equals 2 to t equals 3. So we draw that. Again, we'll get into why we have open circles versus closed circles here. We'll get into that next week. Okay, and then let's see, I didn't really fill out my chart, did I? When t equals 2.1 all the way to, let's say, 2.9, the slopes are negative 1. Okay, and then we can make another chart here, the t and slope chart. Again, the slopes are just the acceleration, because the slope of the velocity is the acceleration. Okay, acceleration. So I think we've got that down by now. But what else do we have? From t equals 3, so let's fill in let's say a 3.1, all the way to t equals 5, or t equals 4.9. So all the way from 3 to 4.9, what are the slopes? Well, we just have to count. You go up 1, 2, 3, 4, 5, and over 1, 2. Okay, so if you count up 5 and over 2, we see that the slopes are 5 halves. Okay, so, oops, that wasn't very good. 5 halves. And 5 halves being 2.5, we just have to graph that from t equals 3 to t equals 5. We have slope. The slope of the velocity curve is 5 halves, or 2.5. And finally, the slope, we can see, let's maybe just do this one in our head without drawing the chart out. The slope right over here, that little section between t equals 5 and t equals 6, happens to be 0. So we might have overlapped that a little bit up there, but nevertheless, it's okay. And so that graph right there is the graph of the acceleration. Okay. Problem number 3. We have plenty of time. Particle moves along a vertical coordinate axis. We've got the position function given to us. S is in centimeters, T is in seconds. The displacement during the first 6 seconds. Displacement would be where you are at the end. Let me write that better. Where you are at the end of the 6 seconds minus where you were at the beginning of those 6 seconds. So that's what we define displacement to be. Okay, well, once you write that down, once you interpret what that means, then you can just figure out what S of 6 happens to be. And I'll use this big space up here. Okay, S of 6 is equal to, and we can see that we just replace T with 6 in the position function, because that's what the position tells us. It tells us what the position is at any time. That's what the position function means. So we're just going to replace, like I said, we're going to replace t with 6 because we want to know what the position is of this moving object at the end of 6 seconds, or at the 6-second mark. Okay. Well, I'm going to pause the video so I don't have to try to stumble through this. I think you guys can figure out what S of 6 is, but I don't want to waste the time of the video figuring out what that is. So what we figured out is that S of 6, or in other words, the position of the particle at time 6 is equal to 8. You should have gotten the same thing. And we can also write underneath that, we can figure out what S of 0 is. And S of 0 is just equal to the only term in the function S that is a constant, because every other term is going to go to 0. Everything that has a t in it is going to go to 0 because we're going to replace t in this function with 0, and what we're left with is -4. And so S of 0 is -4. In other words, where you start is -4, where you end is 8, and 8 minus -4 is equal to 12. And so this particle traveled 12, well, I should say 12 units to the right, and the units are in what does it say? Oh, centimeters. So this particle traveled 12 centimeters, or is 12 centimeters to the right of where it started. Okay, now the average velocity during the first 6 seconds would be how far away this particle is divided by, so it's S of 6 minus S of 0 divided by, well, the number, or the time it took to get there. And the time it took to get there was 6 minus 0, or 6, and that would be equal to 2. Now the average velocity would be 2 centimeters to the right per second. Okay? Find expressions for the velocity and acceleration. We have the velocity being the derivative of the position, and the derivative of the position, I've got it kind of covered up over there, so let me erase that real quick. I'll pause it while I do that. Okay, I'm back. The derivative of the position is the velocity, and the derivative of the position would be 3 times 1/3, which is 1, times t to the 3 minus 1, or 2, so t squared. So the derivative of the first term is t squared. The derivative of the second term is -6t, and the derivative of the third term is +8. So that represents, so t squared minus 6t plus 8 represents the velocity function. And the acceleration then, being the derivative of the velocity, is just the derivative of t squared, which is 2t, plus the derivative of -6t, which is -6, and that's it for that. So for part D, we're trying to figure out what the values of t are in which the particle is moving downward. Okay. Well, we need to figure out then when the velocity is less than 0. Well, what does that mean? Well, it means when t squared minus 6t minus 8, or sorry, plus 8 is less than 0. And so we did this way back at the beginning of, did you get that? Doesn't look like it came through. Less than 0. So we did this again in the beginning of pre-calc honors. We had to solve these quadratic inequalities, and the way we solve them is by factoring t minus 4 times t minus 2, and when is that less than 0? Well, that's when we set up a sign chart. We have the 2, we have the 4, and this is way down at the bottom of your video, or bottom of your screen, so I apologize, we don't have much room here. But the velocity then to the left of 2, so in between 0 and 2, let's pick 1. If we plug a 1 in for t, we get a negative times a negative, and that's a positive. So the velocity is actually positive on the interval from 0 to 2. Okay. In between 2 and 4, we pick a test value like 3. 3 minus 4 is negative. 3 minus 2 is positive, and a negative times a positive would be a negative. Okay, so the velocity is actually less than 0 between 2 and 4. And then when we pick a value to the right of 4, we'll pick some test value like 5. We see that the first factor, t minus 4, is positive. The second factor, t minus 2, is also positive, and so a positive times a positive is also a positive. And so what we see here, down here in the lower left-hand corner of your screen, I'm going to write the answer to this. What values of t is the particle moving downward? And again, downward is when the velocity is negative. And we see the velocity being negative in between the t values of 2 and 4. And that right there, guys, is the answer to this last part. From t equals 2 to t equals 4, the velocity is negative. Therefore, the particle is moving downward. That's the translation. Particle moving downward when v is less than 0. And there's a little bit of work involved in that, but it doesn't mean you can't do it. It just means you have to remember what we did way back at the beginning of Pre-Calc Honors. So hopefully that helps, and I hope you have a great Memorial Day weekend, and stay safe. We'll see you when we get back.